Okay, here we want to evaluate the definite integral. So we have e to the z power plus 1 divided by e to the z power plus z times dz with a lower bound of 0 and an upper bound of 1. So the first thing we're going to do is we're going to decide what we're going to let u equal. So we're going to let u equal what's in the denominator, and therefore we have e to the z plus z. Okay, so now the next thing that we want to do is now take the derivative of both sides with respect to z. So therefore, in step 2, we have du, which is going to equal, well, we know that the derivative of e to the z is e to the z times the derivative of z, which is 1. So that just gives us e to the z. Plus the derivative of z here is going to be 1, and that's dz. Now if you notice, if you look at this, that's all in the numerator here. So now we know what our substitution is going to be. So now in step number 3, let's go ahead and rewrite this. So we're going to go from 0 to 1. We have 1 over e to the z plus z times e to the z plus 1 times dz. And now we're going to put in our substitution. So we know that this is going to be 1 over u, since that's what we defined as u. So e to the z plus z is u. And then what do we determine that e to the z plus 1 times dz equals? Well, that is du. And now we need to change our upper and lower bounds according to our definition of u. Well, we know that u is going to equal e to the z plus z. So that means in our numerator, that's going to be e to the 1 power plus 1. In the denominator, we have u, which is equal to e to the z again plus z. So that's going to be equal to e to the 0 plus 0. So now let's go ahead and then substitute here. So we know that e to the 1 is just going to be e plus 1. We know that e to the 0 is 1, and 1 plus 0 is 1. And then we have 1 over u du. Okay, so now the next thing is, well, what do we know about the natural, the antiderivative of 1 over u? Well, the antiderivative of 1 over u is the natural log. So the antiderivative is the natural log of the absolute value of u with a lower bound of 1 and an upper bound of e plus 1. Now let's go ahead and evaluate according to our upper and lower bound. So we have the natural log of the absolute value of e plus 1 minus the natural log of the absolute value of 1. Well, we know that the absolute value, natural log of 1 is going to give us 0. So therefore, the answer is going to be the following. The natural log of parentheses e plus 1. And the reason why we changed that from the absolute value to parentheses is because the absolute value tells us these have to be positive. So that once we do that, we get the natural log of parentheses e plus 1.